but we're going to do calculations with when you stress a system. Okay, so what happens when you disturb equilibrium? That's what it's called. So this first one, we're just going to walk through it step by step. Okay, so we're not even going to show the whole problem asked. The first thing that we're going to do, so if you're not given KC, you have to find it, which we know how to do, right? That's a simple plug it in, products over reactants. Okay, so here it says we have an equilibrium mixture. So we've placed A, B, or really A into a vessel, and it formed B and C, and we waited long enough for it to be at equilibrium. Okay, what does equilibrium mean? What does that mean? Okay. Yes, ma'am. Told you, Tina, you are on fire today, girl. Okay, so if we look here, we've got 0.20 moles, 0.3, and 0.3 moles per liter, which is what? Moles per liter is molarity, right? So you're already given the molarity. You've got to pay close attention to that if you're given moles or molarity, and depending on, so I didn't give you a volume of the vessel because you don't need it here, right? It's already telling you the concentration. Okay, so the first thing we have to do, if we're told equilibrium mixture, that means we can plug those numbers into this, right? Okay, so that's what we'll do. We'll take our 0.30 times 0.30. It's all a 1-to-1 ratio, so it makes it simple here. You don't have any exponents. Okay, over 0.20 molarity. Okay, so when you do the math there, you should get 0.45. Okay, so KC okay, everybody with me on this so far? Easy enough? Okay, here is this red arrow. Here's our stress. Okay, so this is different problem because now we are stressing the system. Okay, there's really two ways we're going to look at. There's three total that stress the system, but we're not going to look at temperature. Is an increase or decrease in concentration, also in volume and pressure. Really, they all go back to concentration, really. Okay, so if we now stress, this is the part of the equation or the word problem that you have to recognize so that you know what to do. Okay, there's one type of problem where you're given equilibrium concentration, you plug it into KC, voila, you're done. Takes 2 seconds, not really, maybe a minute. Okay, if you have a problem where you need to use the ICE method, you have to recognize it. You're given equilibrium concentrations or initial concentrations, and then you're given one equilibrium concentration, and then you use the ICE method. Okay, this we were given equilibrium, but now we've changed that. Now we've added a stress. So our stress is the volume of the reaction vessel was suddenly doubled. Okay, so let's say water was our solvent here, and we suddenly, say we had a 1 liter vessel, we suddenly doubled it to 2. Okay, it's not specific here of what exactly was done. Okay, so first things first, the temperature is constant, and now we want to know what the new equilibrium. So if that's in the word problem, new equilibrium concentration, that means you're going to have to go through this process. Okay. All right. So first off, so if we double the volume, what have we done to the concentration? Halved it. Exactly. That is a mistake. One's just like this on the exam, and students do the opposite. Okay. If you double the volume, you've now taken whatever your concentration of your molecules here, A and B, you've doubled the volume. So think about if you had a salt solution. So say you had it in a 100 milliliter beaker and you swirl it around, okay, and you were to taste it, it's going to be pretty salty, right? Just like sweet tea, okay, if you put a large amount of sugar, okay, in a small area. But if it's too salty or too sweet, what do? Add some more water, exactly, to make it less concentrated. Okay, it's the same idea. Okay, so exactly, you're going to halve the concentrations. Okay, this is where Q comes in because we're not at equilibrium, right? We just totally threw our equilibrium off by stressing the system. But we know that we're going to half. So this used to be 0.2, right? And this used to be 0.3 and 0.3. Okay? So we take our 0.1515 divided by 0.10. It's still a 1-to-1 to 1. Okay? And we get 0.22. Okay? So now we do what now? Well, you just use 2 significant digits. Do what now? Well, technically there's a rule, and we don't do a lot because it's really nitpicky, but if you have a 2 in front of a 5, then you round down. So if it's an even number, you round down. If it's odd, you round up. But it's very nitpicky. Mr. Green, one of our adjuncts, he is very particular about it, but so it's 0.22. Do what now? Yeah. Did you know that rule? Have you ever heard that rule? Okay. Yeah. It's in there. It's even in your book. It talks about it for about 2 sentences. So, all right. But if you put 0.23, I'm just not personally that nitpicky. I would accept it. So, all right. Q is less than KC, right? So here's KC. Q's down here. So the whole point of these first 2 steps is to determine this. You're monitoring the reaction. Q is now less than KC, so the equilibrium is going to have to shift to the right. Okay? So if it's shifting to the right, what are you forming? You're forming positive what? Products, yes. So you're forming positive products, and you'll see why I put positive there in a second. Okay? This determines the sign, positive or negative, for what we're about to do, the ICE method here. Okay? For the change in the ICE method. Okay? So, all right. So if we set up the ICE method now, we have A, B, C. Okay, we have new initials, right? Because these were equilibrium, the first ones we were given, the 0.2, the 0.3, the 0.3. We now stress the system, and you guys told me that you would half the concentration, right? Okay, so there they are again, 0.15, 0.15. Okay, this time we're not given anything, we don't have any insight into what these equilibrium concentrations are, okay? So what we have to do is we have to use what we determined here. We determined that we are forming products. Remember, this reaction could be shifting either way. So that means that we're going to have positive change here. Okay? All right. So, but we don't know how much. So that's where we just have X. That's what we're trying to find. So we're forming product because Q is less than KC. Okay, so we have 2 products here, so it's going to be the same, plus X and plus X. Okay, and that's what we're going to solve for. And then we're going to be losing reactants, right? We're using up reactants, forming products. Okay? So now, if you take these, 0.15 plus X, 0.15 plus X, and 0.10 minus X. So that's what we get. Okay, which doesn't really, we can't stop here because we need to find out what X is, right? Okay. Is everybody with me so far? Okay. All we did was find KC, KQ, find Q, and now we used our Q to tell us what our sign should be here. Okay. All right. Any guesses to what we're going to do with it now? How are we going to find X? Right? You are going to use the quadratic formula. One of the most forgotten things, okay, this is the same. Nothing changed here. Okay? You're going to set up your KC. Okay, this is what we're trying to find, right? We're trying to find our new equilibrium concentrations. Okay? You're going to take this, which is an X, and you have an X here. Okay? one of the most forgotten things, and it leads you nowhere, is if you don't set it equal to 0.45. Okay, where did I get 0.45? Right. And that doesn't change, right? We've established that. It's a constant. It doesn't change unless we change temperature. So we have to set it equal. So if you want to star that, circle it. You have to do that, or you just keep going and trying to do algebra, and you never get to your quadratic equation. Okay? All right. So this is where algebra comes in. So what I want to tell you, we're going to practice these. This is, of course, us going through one. We'll go through another. Okay? I don't know how much individual practice we get. If you have algebra issues, okay, and that's fine, I can help you, but it's going to need to be a little bit later. We need to get through this and try not to just stress over the fact that you couldn't get the algebra right, and then we can fix your algebra later. It takes me quite a few minutes to figure out, look at what you've done and figure out what you've done wrong. Okay, so these problems take me a while to grade because I'm trying to figure out which way you're trying to move to which side of the equal sign or whatever. So if you have an algebra issue, just kind of try your best, and then we'll work on it after. Okay, because a lot of times when I teach this, students get so stressed out about the algebra, and then they don't listen to the rest, and then they're completely lost. Okay, so if we set this equal to 0.45, okay, most all of you have probably heard of FOIL, right? Okay, so that's what you're going to do. Okay, you're going to FOIL it, okay, and you're going to go through and you want to set everything, so you want to come up with a quadratic formula. So when you FOIL this is what you should get, equal to 0. So I want everybody just to take a few minutes. Like I said, we're not going to get bogged down on the algebra part. FOIL it, bring everything to one side. You know, some students go over here, some go over here, okay, and set it equal to 0. Okay, now you have a quadratic equation. And then we're going to use our quadratic formula. Okay, so take just a couple minutes. Make sure you get the same thing here. If you don't, just make note of it. I've checked this for 3 years now, and I've yet to find this to be wrong, so I think it is correct. So if you don't get it right, just circle it, and we'll come back to it. So you should get an x squared, an x, and then just a numeric value equal to 0. That's just the way I rearranged it. So you may rearrange differently. Okay, so this is just kind of showing after I fooled it. Do you see it now? Okay. Okay. Anybody getting it yet? Okay, so then you label it for your quadratic formula as A, B, and C. Okay, the quadratic formula is what? Negative B, so minus the square root, B squared minus 4AC, all over 2A. Yep. No, it's all adding and subtracting. So if you move it to the other side, then if it's yeah, you don't divide anything. Yeah, it's just moving. If you flip it to the other side, you got to flip the sign.
I'm subtracting.
Okay, maybe another minute on the algebra. Yep. Yeah. Yeah, it's just full on the other side. Yeah, it's just funny how it works out. Plug it in your calculator and you'll see. It works. It looks funny because she's talking about the 0.045. Well, if you take 0.0, so if we move, let's see, which side did I move to? I think I moved everything to the left, it looks like. If you take 0.045 minus 0.0225, you get 0.0225. It's just a coincidence that those numbers end up being, yeah. Somebody else had that same question, but when you subtract or you move it over, you get the same number. Yeah. All right. Everybody out there, or circled it if you didn't get there. Okay. So if you look over here, how I did it is I foiled this. So first, outside, inside, last. That's where I get my x squared. Then I go ahead and brought this over here. So I multiplied 0.10 times 0.45, 0.45 minus x times minus x. And then it doesn't matter. You can move everything over here or move everything to the other side. Okay? So you can't forget about this term here, too. Okay. So now you want to plug in, I've got the answer up here, but write down your quadratic formula. Okay, so here it is. And then plug in those values. And remember, it's negative b. So if you already have a negative b, or in this case you don't, but you got to switch it to positive. So be sure you get your signs right. One of the most forgotten is to take the square root of this. Okay. And then it's all over 2a. So I would do the top part, okay, and then 2a and divide it into that, whatever 2a is. Here it's just 2. Okay. And since it's plus or minus, you can get 2 answers. So we've got to evaluate which one it would be. This one's pretty easy to see, but
Go back one slide for just a minute.
okay, so take negative b, which I believe what was our b? 0.75, yep. And b squared. A is 1. So take the square root. Make sure you do that. And then calculate both. So do the plus divided by 2, and then subtract the two numbers divided by 2. I'll give you another minute to work out the algebra. Like I said, you just need to understand the format. If the algebra is not working out quite yet, we can fix that. probably in your calculator. Do everything in pieces if your calculator's not going to allow you to put it all in. Mine will let me put everything in there, but okay. This problem's not that it's hard, but as you can see, there's just lots of room for error. So you forget one thing and everything gets off. Okay, another minute on this. Did you get it, Aaron? I think?
I think so. I just didn't do the bottom.
Fooling it.
Here.
So you just needed to bring that up and okay. So we get two values. Here we get a negative and a positive. Well, we can't ever have negative concentrations, right? So we know that this 0.03 molarity, okay, that is what? What did we just find? What were we solving for? X, right? So go back to your ICE method, and we plugged in 0.15 plus X and 0.10 minus X. So you just found X. Okay, that was the whole point. Okay, in the next problem I'll show you, you'll get two numbers that are a little bit closer, and you have to figure out which one's right. Okay, this one's pretty easy to see. We can't have negative, so it's got to be the other one. Okay, so now we know X, but we're not quite done. So another common mistake, students stop here. They find X, woohoo, yay, I'm done. Well, that's not what the problem asks, right? It asks us for the new equilibrium concentrations. So all you have to do is go back to your ICE method, okay, where you had X in there, okay? So if you look back at your ICE method, A was 0.10 minus X. So now you plug in X, 0.10 minus 0.03. So our new equilibrium A concentration is 0.07. B and C were both 0.15 plus X. Okay, this is where your sign becomes important. Okay, where did we get that plus from? How do we know we added or gained product? Remember? By comparing Q and seeing which way the equilibrium was being driven. Okay, so now we add, because we gained concentration of product by stressing the system, and now we have 0.18 molarity for both B and C. This is the final answer. These are your new equilibrium concentrations. Okay? All right, so take 1 second and read through this problem. Okay, we're going to use the same setup. A yields equilibrium arrow with B and C. Okay, that way we don't have to reinvent the wheel here. Okay, I've written in right there where the stress comes in. Okay, so I want you to just take a second to read this. Think about how you would start this. Using the same problem, same idea. So this one just gives you, it goes ahead and gives you Kc. I might do that. Or I may say, here's the equilibrium concentrations, find Kc. Here we're just trying not to reinvent the wheel. We're trying to get the process down. So Kc is 0.45. So great. You don't have to do any calculation there. Okay. It tells you, recall, the concentrations were 0.2, 0.3, and 0.3 at equilibrium before it was stressed. Okay? That's just from the previous problem. All right, this time we are going to half the volume. Okay? So if we half the volume, what happens to concentration? Increases or it doubles, right? So it's the opposite. We have the opposite going on here. Okay, so if we double our concentrations, now we're going to have 0.4, 0.6, and 0.6, right? Okay, and this is what we should get. So Kc is 0.45. Okay, if we double our concentrations, that's here for Q, right? Because we've now stressed the system. We're not at Kc anymore. Okay, and Q is 0.9. Okay, Q is greater than Kc, so which way is the equilibrium going to drive? To the left, right? Okay, yeah. So it's going to go to the left. So it's going to be favoring, we're going to get positive reactant. Okay, everybody with me so far? We were given Kc, we found Q by doubling the concentration because we half the volume, and now we compare Q and Kc, meaning our sign is going to be opposite in our ice method. Now we're going to have positive reactant because it's driving this way, and we're going to be losing product, which is generally not really what you want in most cases. Okay, so if we look here, our new initial are after we doubled our concentration, so we get 0.4, 0.6, 0.6. We know that. Okay, now our sign's different. We have positive plus X on the reactant side because that's the way we are shifting, and we're losing products. So we have minus X and minus X for B and C. Okay, so we bring that down, we get 0.40 plus X. Remember, we're finding concentration, so it's molarity. Okay, and we have 0.60 minus X, 0.60 minus X. And then, this is one of the most forgotten steps, and then you get stuck and you can't finish it out. You put this back into Kc. Okay, we're trying to find X at equilibrium. Kc means at equilibrium. So we plug in products over reactant equal to 0.45. Okay, you cannot forget that we know Kc, so you plug that in. Okay. All right, so I'll give you a minute to foil this. Okay, remember to bring this up. Okay, I think I moved everything to the left, so you're going to isolate all of your x's and your numerical values all on one side, and you should get your quadratic equation. Okay, so I'll give you another few minutes to be sure you get the same answer here. Okay, that top 0.60. Yeah, so you're going to do this times that. That's first. Then outside, 0.6 times just X. And inside, this and this. And then last, this and this. Yep. Shouldn't be. Yeah, you gotta get a positive. You're already plugging it into the quadratic formula. Yeah, you should get a. Yeah, you should get a positive. So somewhere you must have made it just a little. .45 because KC is what you're trying to, you're plugging it into the KC. So KC is .45. Okay, so now we're going to plug it in. So you've got your A, B, and C. Everybody get x squared minus 1.65x plus 0.18. What'd you get? I'll have to come look.
You're adding the 60 and the 69.
You may have added when you were supposed to subtract. Here, I'll look at it real quick. If I can't figure it out, then just write this down and we'll figure it out later. Okay, did you do your other part? Okay. Okay, this is equal to 0.45. And you've got, that's what you're doing, 0.40 plus x. You got to bring that over here. Okay, so plug those into the quadratic formula. Should look something like this. And this time, don't worry about this part right here. I'll explain that. Just see if you can get to 1.5 and 0.12. Okay, and then we got to decipher which one's the best answer. Do it. Yeah, I make updates to it all the time, so. No, it's right. Keep going. Oh, I just need to update the. Yeah, that's an older PowerPoint. I don't know why that one is uploaded on there, but yeah, go back to it. It's on there. It's just got. So. Right there. Yeah, it's just an old one. I used to, yeah, but it's still the same thing. I just broke it down into different pages. Yeah, I'll upload the newer version. I change it all the time, so. Give you another minute to be sure you get 1.5 and 0.12. If you are awesome at math, still work these out because I have students to not do them while we're practicing, and then on the test they kind of go blank or they didn't even practice it. So be sure you at least practice it a couple times, even if you're a math whiz. All right, are we getting 1.5 and 0.12? Most everybody? Yep, we're going to talk about what that means, though, in a second, and how to decipher that. All right, we have two positive values. We got to figure out which one is correct. And what you do, so here it tells you the limit is 0.60. Okay, do y'all remember your limiting reactant? Okay, if you go back and look at your ice method here, okay, we can only lose 0.60, right? Because both of these are really, we're limited by either of them, and they're the same. So it has to be less than 0.60 because if we can't lose more than what we have, right? That defies the law of the conservation of mass, right, and matter. So that's where that 0.60 comes from. Okay, if it's bigger than that, it can't be because it can't lose more than what you have to begin with. That makes sense? Okay, so then we just plug in that 0.12. So we started with 0.4 plus 0.12, and then B and C were equal, so we subtracted 0.12. Okay, so the equilibrium concentrations, the new equilibrium concentrations are now this. Okay, so we were given equilibrium concentrations to begin with to find Kc. In this specific case, we were just given the same number. Okay, you find Q so that you know which way the reaction shifts. Okay, then you set up your ice method to solve for X. Based on your Q, which way it shifts gives you the positive or negative sign. Then you simply FOIL once you set it equal to Kc. Okay, like I said, that's probably the most forgotten step right there. And then put it in your quadratic formula to solve for X. Okay. So it's not really that it's that hard. It is, a pattern you got to practice. You got to be sure your algebra is on cue. There's just a lot of room for mistake, and with this problem, most students learn from a mistake, so they forgot to square root, and they keep getting the answer wrong. Well, guess what? Come test time, they're not going to forget to square root because they kept doing it when they were practicing. Okay. All right. Okay, so we stress both of those problems. We're stressed based on volume, right? Volume, pressure, concentration. Okay, before we even start this problem, we're going to have a stress, and we're going to have a stress where we increase concentration on one side of the reaction. In this case, okay, everybody listen up, you can go ahead and find the numerical value of Q if you would like, or you can use your knowledge of Le Chatelet's principle. Okay, if we know, so here we're going to add, here's our stress. Add concentration of our chlorine. So which way are we going to shift the equilibrium? The other way, right? Everybody with me on that? Okay. So you don't necessarily do it. If you want to stay in that process of finding Q, comparing, that's totally fine. But if you want to just use your knowledge of Le Chatelet's principle here, you can do that. Okay. If you stress by adding 0.80 moles of chlorine, and you shift to the right, or excuse me, to the right, okay? So if you shift to the right, that means what's our sign going to be when we get to our ice method for our X, for the products? It's going to be plus X, and that's all Q is telling us anyways, right? So we don't really care what that number is besides, is it bigger or smaller than Kc? Okay, so either way is fine. Okay, so let's look at the problem. We have a 2-liter vessel, so be careful here. We know we're going to have to divide. Okay, we are given equilibrium moles. Okay, tells us that. Okay, you're going to divide all of those moles by 2, right? Why? So we have to get not liters, we have to get, what are we looking for? Molarity or concentration, right? Moles per liter, concentration. Okay, so the first thing you're going to do is go ahead and find the equilibrium constant, which is Kc or Keq. Okay, so divide all those by 2. Everything's a 1-to-1-to-1 ratio. Makes it easy for you. You don't have to square anything or anything like that. Okay, so the first thing you're going to do, you can get a few points right here on this problem just by finding Kc. Okay, so do that before I switch slides. And right here where it says molar concentration, that's the same thing as molarity, so it's just a different term. Okay, you know you're going to have new initials, but this time it's a little different. You didn't change everything, right? When we did the volume, we doubled or halved all of our concentrations. Well, here, the only thing that we're changing is the concentration of chlorine. Okay, what's the concentration of chlorine here that we're adding? What concentration are we adding? Very good. Why is it 0.4 and not 0.8? You're still in a 2-liter vessel, so you have to divide that number by 2. Okay, so it's 0.40 molarity of chlorine. So basically, we're just going to stream in some more chlorine gas into this reaction. So that's what's going on. Okay, so if we found Kc, all right, did everybody find Kc? Okay, I'll give you a few minutes. I want you to try to work this one, okay? So find Kc, and then set up your ice method, okay? The only difference here is your new initial, it's going to change with respect to the chlorine. Okay, so we're going to put this one out. Kc is going to be equal to, looks like product is COCl2, so it's going to be 0.60 molarity, right? If you divide it by 2, divided by 0.3 times 0.1. Okay, so what did everybody get? 20. Very good. So we found Kc. Okay, this is what I'm going to show you both ways for Q. All right, if you want to go ahead and find Q, you can do that, okay? We'll plug it into that you did reactants over products. Or why do you have, so you only have one product?
Oh, it just said P6, so I just
No, you have product. That's your only product over reactants. Yeah. All right, you only have one product, so you're going to have that 0.6 divided by these numbers. Okay. Yes. You divide all of them because they're in moles. Molarity is in moles per liter. And if you have a 2-liter vessel, you divide that by, yep, so that gives you 0.6. Okay. And it's always products over reactants. And then you divide that by 2 and that by 2, and that gives you that.
I didn't see that. I wasn't seeing that I had to divide that by 2.
Yes, all of them. Okay. Q. This is where you can find it if you want to, or you can use your knowledge of Le Chatelet's principle. Okay, if we increase the concentration of chlorine, we know we're shifting to the right, which means Q had to be less than Kc. If you want to do this, that's fine with me. So we would say Q equals product concentration, what was it, 0.60 divided by the reactant. So one of them stayed the same. Which one? CO was 0.3. Okay. And then now we take our, what did we have? We had 0.1 of the chlorine. Okay, and now we're going to add 0.4. So that gives us what, 0.5? Okay. So, okay, if you do the math there, you're going to get the same thing. Q is less than Kc. Okay? Either way is fine with me. Anybody confused on that? Okay, just use your quantitative, relationship in your mind, or you can see it if you want. Okay? All right, so this is what we've already done. You found 20. Anybody not get 20 for Kc? Okay? Here, I didn't show Q, but we know Q is less than Kc, meaning it's going to shift right. Okay? So up here, these were our original concentrations, and then we added 0.40 to our chlorine concentration, right? Okay? So now these, which is the same thing that I plugged in here, these are our new initials. Okay, if you want to just add the 0.4, you don't necessarily have to show me that this step right here if you don't want to. Okay, but all we did here, we didn't double or half everything. All we did was increase concentration of chlorine, so we show it right there. And now here's our new initials, which we could plug into Q and see that Q is less than Kc. Okay? All that tells us is it's shifting right. So it's going to give us a positive X for our one product and a negative X for our two reactants. Everybody with me? All right, who's losing me? Raise your hand. Everybody? Okay. Now, we just bring it all down to in our ICE method, and this is how we solve for x. So we take 0.3 minus x, 0.5 minus x, 0.6 plus x. Okay, where did I get minus and plus? From Q, right? In which way it's going to shift. Okay, then I take all this and I set it equal to 20. Okay, why 20? That was Kc, right? And we know it. It doesn't change. So we can set it equal to 20. All right, we put it back in the form, product over reactants. Don't forget that. I think you were trying to be sure you notice, that you only have one product here and you have two reactants. Yeah, it doesn't matter. Just you label them as products or reactants. Yeah. Yes, always. Yes. These can be a little more complicated than what we're doing right now if you had to put your exponents there. So everything's a 1-to-1-to-1, okay, but that's not always the case, right? So we know we can have, so that throws in even more algebra and things, but we'll get to that later. Okay, so we set it equal to 20, and now what do we do? Bullet, isolate everything on one side, and do the quadratic formula to solve for x. Okay, so you can practice these on your own. You should have some time here. But when you reduce it, you should get 20x squared minus 17x plus 2.4. You should always get an x squared, an x, and just a numeric value. Okay, because that's your A, B, and C for the quadratic formula. Okay, so when you plug it in, we get 0.67 and 0.18. All right, so these both sound pretty reasonable. We don't have a negative. All right, so if we look back at our ICE method here, this is what we're losing, right? These are our reactants that we're losing. So our limiting reactant is this one, right? So our X has to be equal to or less than 0.30. Does that make sense? Okay? So if we look back over here, that eliminates our 0.67, right? Because 0.18 fits in that less than 0.30. And now we just go back and we plug in that 0.18 in for X. and you get your new equilibrium concentrations. Okay? You find Kc. If you're given Kc, then that's just one less step that you have to do. Okay? You find Q. Q is based on the stress. If something has to stress the system, meaning in our examples, volume or concentration. Then you find Q. If you want to just use your knowledge, you don't have to always find it. You can know which way it shifts. Okay? Which way it shifts tells you if it's positive products or negative products or vice versa, or whichever way what our signs are going to be for the ICE method. Okay? You set up your ICE method to solve for X. You plug it into Kc again, equal to whatever that value is for Kc. You full it, you put it in the quadratic formula, you find X, and then you go back and you plug in X for your concentrations to get your new ones. Okay. All right, we have just a few minutes. I'm going to pull up. So hopefully some of you have this printed out, and I think one of them is almost identical to what we already went over. Okay, but there's two problems these are the ones for class. So we'll probably start with these even on Thursday, but I want you to try to start them. And based on what we've done, you can look back at your notes, but try to do them. I think one of them, like I said, is identical to one we did. Try to do it and then figure out where your hang up is. Where are you messing up? Where are you forgetting a step? Okay, so I'll pull these up. They're on Blackboard, but I'll pull them up here. If you've already got them printed off, you can go ahead and start. All right, while I've got this up, here's your homework. Number 1, number 2, and number 3. And we'll probably do all of number 3 in class on Thursday. So we should have time, I would think. So all of these we've worked on in class. So if you've actually worked hard in class, you should have. So we've worked on this one for a while. There's 1. Here's number 2. This is what we're doing right now. And then worksheet number 3, we'll probably do the whole thing on Thursday. So no excuses for no homework. Okay, you should have pretty much done most of it in class. All right, so here's one. Yeah, is that just the steps?
Mm-hmm. Yeah, I printed them
Yeah.
off.
Yeah.
I applied this to what we're doing right now.
Yeah, thank you for mentioning that. Right here where it has the steps, this is something you could print off for yourself and may help you while you're practicing. It gives you what I just told you. Step 1 is to do this. Step 2 is to do this. Step 3. So you can use that as you're working the problems if you need to. So it's just a little kind of cheat sheet, I guess, if you need it for homework and practice. All right, so try to work number 1 here for a few minutes. We've got a few more minutes of class, and see how far you get and if you have any questions. If you and your partner want to come a little early to lab, maybe 12:40, 12:45, you can, but be sure your partner is also there. Y'all need to start together. So Okay, so they all have a little variation. This time you're adding A and B. So you're going to be driving the equilibrium quite a bit further to the products. Good. Got the first step. So yeah, first now you want to think about Q. So you can either find Q if you want to, or just based on your knowledge, if you increase A and B, which way are you going to shift the equilibrium? If you add to one side, you always shift to the other side, right? So that tells you that Q had to be less than KC, right? In order to shift to the right. Okay, so you can do that. Or if you wanted to, you would add, go back to your A, which was originally 0.2, and you'd make it 0.32, right? Because you're adding 0.12 to it. Okay, does that make sense? Okay, the problem says you're adding 0.12 moles of A and B. That's your stress. Right. So, right. And those are your new initials, basically. Yeah. They don't have to be, but they can be. What did you find for Q? Yeah, I have 1.56, but yep.
I mean, 1.56, that's my guess.
Mm-hmm. So Q is less than KC. If Q is less than KC, it shifts to the right. I don't know. I think you may have said it backwards. If Q is less than KC, it shifts to the right. So it makes your product, your X for your product's positive, and your reactants are negative X.
So these are positive X,
Let me see.
I'm not sure. I was going to add those.
Okay. All you need to do is get your new initials, meaning you just need to add the 0.12 and get your 0.32, 0.32, 0.4, and 0.4. Yeah. Your new initials, so you don't double or half everything, but you do add to your A and B. Your new initials should be 0.32, 0.32, and then 0.4 and 0.4 for C and D. That's where you start with your ICE method. It's minus because you're saying it shifts to the right, right? Because Q is less. So if it shifts to the right, that means you're forming products. Yes. You're consuming reactants and forming products in this case.